Welcome, everybody. My name is Scott, and today I'm going to be talking to you about test-driven development with C# going from Padawan to Jedi. So before we get started on this talk, I just kind of want to level set real quick on who the audience I had in mind when I made this talk, because there's lots of other talks you could attend, so I just want to make sure that you're in the right spot. So really, it's any of these people on this list here. Really, I'm targeting .NET developers, so if you haven't used C# before, this talk may or may not be for you, although a lot of the patterns that I'm going to talk about apply no matter what language that you're using. But I find a lot of people don't even know kind of where to get started with TDD, so that's kind of the genesis of this talk. So we'll kind of assume that you haven't really seen TDD before. But hopefully, even if you're a seasoned TDDer, you might pick up a couple things as well. And I'm not really going to go into like some basics about how testing works. So if you haven't seen that before, hopefully it's not too crazy, and you'll be able to pick up things along the way. So we're going to talk about all these different things here. We're going to talk about what different types of tests are there, because there's trade-offs depending on what kind of tests you write. We're going to talk about what is TDD, why you should care about it exactly, why you should be doing it. And then we'll also talk about like what should you test, because that's a pretty common question people ask me is like, hey, what should I be testing in my application? And I'll do a live coding demo with this podium at like a 45-degree angle, so we'll see how that works out while I do some live coding as well. But my goal out of this talk, I've got really a couple goals here, is really learn just kind of best practices on how to write tests, which I really hate the term best practices because it assumes that there's only one right way. But really, that's just kind of a synonym for, hey, these are my opinions as of this moment, but I might change them here in the future. And then hopefully you can learn how to kind of get started writing doing test-driven development with C# specifically. So who am I? I'm the director of engineering at a company called Lean Techniques. We're a software consulting company based in Des Moines, Iowa, which is kind of in the center of the US. But we work with companies from Fortune 50 companies down to startups and kind of everything in between, both helping them write better software, where we'll actually put people on teams to kind of teach them how to write better software, as well as just building software as well. The co-organizer of the Iowa.NET Use Group, Microsoft MVP, friend of Reg8, and I blog as well. I have already posted these slides up on my blog. It's just my first and last name, scottsauber.com. And if you want to follow me on Twitter, I'm just Scott Sauber there as well. And I refuse to call it X, so I'm just going to call it Twitter. All right, so let's just kind of jump into it. But before we kind of level set on TDD, I just want to level set on different types of tests as well. So why do we write tests? Well, probably the primary reason is we want confidence that our application actually works. Because how many people have ever made a change over here in this part of the system and it broke something completely on another side of the system? Anybody? Okay, about half the room, and the other half of you are absolute liars because you totally have done that. The other reason why we write tests is we want to minimize manual work. So we don't want to have to go around and say like, oh, I'm going to go click all these different buttons and make sure that I didn't break the thing, I didn't break our primary revenue generator, all that kind of stuff, and we don't have like a bunch of QAs behind the scenes manually testing things that we could just write automated tests for. So then the QAs can actually do some more interesting work. And if you're interested in talking to me about that later, just let me know. And we can talk about what I think about QAs. I do think that they are still useful, for the record. The other reason is we want to document the behavior through our tests. So a lot of times, sometimes code can, hide what the actual behavior, what the intent of the system is. So by writing tests, we can actually document, like, hey, this is what the application should actually do. And so then you don't have to worry about, like, hey, what does the application do? Like, I got to go read the code. Oh, all this stuff is in stored procedures, which is terrible to read. If you can actually have the tests, they can actually read to you what the behavior should be in a really easy-to-read format. All right, so now that we've talked about, like, why do we write tests, let's talk about what different kinds of tests are out there. So the first one is unit testing, so we'll talk about that in a little bit, because that's an interesting topic. We'll talk about integration tests. That's also kind of an interesting one because that can mean a lot of different things to a lot of different people. And then we'll talk about end-to-end tests as well. There are different types of tests out there, like acceptance tests, smoke tests, load tests, stress tests, like all sorts of different types of tests. But we're going to focus on these three primarily here in this talk. So the first one we're going to talk about is a unit test. And this can mean a lot of different things to a lot of different people. But I really like this description of that it should follow this first principle. And so that's an acronym for FAST, meaning the unit test should run in like milliseconds or less, not multiple seconds. It should be isolated, meaning it should only kind of talk to itself. So if you have a method in C#, you shouldn't be communicating with like other classes and other methods and things like that. You should kind of be targeting that method by itself. It's repeatable, so if you run it 1,000,000 times, you get the same result every single time, and you shouldn't have any sort of flakiness that happens where, oh, sometimes it passes, or after this time of day, this test never passes, some of those kinds of things. Self-validating, meaning it should contain its own assertions and should be able to like say like, hey, I expect this to happen when you do this kind of thing. And then it should also be timely, meaning you should write the tests first, and we'll talk about what that means a little bit later. You might hear some people also use the term solitary, meaning like these tests don't communicate with other classes or things like that. They just kind of talk about the logic that is in their method itself. I really like this term solitary, meaning like, hey, I only communicate with myself. Because some people will classify unit tests more as, it only talks to things in memory, like it doesn't talk to a database or things like that, which means it could communicate across multiple other classes. I don't really like that definition. I think that's more of an integration test. So what an integration test is it just invokes different parts of a system together. So it could be multiple classes communicating with each other. A lot of people think integration tests always means talking to a database, talking to the file system, talking to an API, getting some sort of I/O involved. I don't really use that definition. I prefer this definition where like it's just communicating with multiple things. It could be a database, it could be an API, it could be the file system, but it doesn't have to be. So it might have external dependencies, like I mentioned, and it's usually less deterministic if you don't have what's called a controlled dependency. So if you have an uncontrolled dependency, meaning you're calling out to an API that you don't own, then you might have some flakiness where if you run it 1,000,000 times, it might fail sometimes because that API goes down. So that is a trade-off with some integration tests, is if you don't have a controlled dependency, and if you're like, let's say you're using like a shared database and you're not using like a Docker database that you can just spin up locally, then these types of tests might not be as deterministic. It's also really useful for testing legacy code. So if you ever deal with things like, the system's like really hard to change and things like that, what I like to do for things like, for situations like that where I'm dealing with legacy code is I like to write some characterization tests around the system and say like, hey, when I pass in this input, I get back this output. Like I don't really care how it does its thing. I just care that when I pass in, this data to this API, that I get back this response. Or maybe I'm even inspecting the database, like, hey, when I do this thing, then the database should look in this way. And I don't really care what happens in between. So that way, once I get those characterization tests in place, then I can start refactoring to my heart's content and start changing a lot of things. So similar to how there's also the term solitary for unit tests. There's also this term sociable for integration tests, which means it's communicating, it's socializing with other parts of the system and isn't just kind of solitary by itself. And I really like that word to describe integration tests. So for end-to-end tests, really this is just a type of integration test. Like how many people have done anything with like Selenium, Cypress, Playwright, any of those types of things? Okay, probably a third of the room or so. Cool. So that is a type of end-to-end test. And really what an end-to-end test is it invokes the system from like its entry point all the way to its end. So if you have a web app, that's where a tool like Cypress, Selenium, Playwright, any of those start to come into play, where you're actually interacting with a browser. But an end-to-end test, let's say you just have an API and that's what you deliver. You could have an end-to-end test that doesn't actually interact with a browser because your entry point is the API, right? But most people think of browser tests when they hear end-to-end. This will have external dependencies. So if it's a browser test, for instance, like at minimum, you're spinning up an actual browser. And so you will have some sort of external dependencies at minimum there. and it won't be all in memory because, again, you're spinning up that extra process to spin up the browser. Even if it's a headless browser, you're still spinning up another process. And usually this is the slowest form of integration test. So usually spinning up an actual browser and interacting with things usually takes a lot longer than just spinning up a class in memory and testing that class. So that is a trade-off of end-to-end tests. And it's even less deterministic, typically speaking, than integration tests if you don't have uncontrolled dependencies, or I've seen a lot of people put waits in their system where it's like, hey, wait for this element to show up, or they just thread.sleep things, which you should never do, just to wait for things to show up. So it can even be less deterministic than your typical integration test. So then the question is, okay, how many do I create of each? And the answer is, any guesses? It depends. Right, the answer to everything of it depends. Well, you have to kind of ask yourself, what does it depend on? So there's a few different testing strategies out there. So one is called the testing pyramid, which the idea behind the testing pyramid is you have a lot of unit tests kind of at the bottom level of your pyramid. And so those are really fast and really cheap to create. The downside of unit tests is they sometimes don't give you the most confidence that your system actually works. So you get this nice little trade-off of hey, they run fast, they're really easy to make, but they don't always give you the most confidence. And as you kind of move up the pyramid, if you follow the testing pyramid scheme, you have less integration tests than you do unit tests. And integration tests start to get a little bit slower, a little bit costlier to maintain because you might have to set up some database data, for instance, or things like that. But at the trade-off of you get more confidence when those things succeed. And then obviously end-to-end tests, or in this case it says UI tests, at the top, where those are the slowest. They're the hardest to create, but they also give you the most confidence. So it's kind of, the testing pyramid is one paradigm around how many do you create of each. So the answer is really, it depends, because there's also a strategy called the testing diamond, which you can kind of see here, where you have less unit tests, more integration tests in the middle, and then less UI and end-to-end tests. So this is another strategy as well. And I would say typically on front-end code, I kind of lean the testing diamond way, and on back-end code, it kind of depends. Sometimes I'm more pyramid-y, sometimes I'm more diamond. Just kind of depends on the situation. We'll talk about that a little bit later. So these are kind of different strategies. You might have also heard of the testing trophy. That's also popular in the front-end space. Really, these are just kind of ideas about how many do you create of each. So I would love to sit here and tell you, oh yeah, you should have exactly 60% unit tests, 30% integration tests, and 10% end-to-end tests. But really, it depends on what you're doing. So you kind of have to analyze what makes sense for your situation. And so how many people have seen memes like this, where hey, I've got did that play? Nope. I've got a unit test that passed for this lock, but then when I went to integrate it with a door, it doesn't actually do anything, right? And so this is where you might see things that are hey, all my unit tests pass, but my integration tests do not. Or oh, I only have unit tests. And it's cool, that works great up until you go to integrate stuff, and then things might not actually work. There's also a funny one where somebody's got a hand dryer in a bathroom, and it's right next to a trash can with a plastic bag, and basically they take the towel to wipe off their hands and throw it in the garbage, and then the dryer goes off and spins the trash all around. That's right below it. It's kind of funny. I should have put that one on here too. So, all right. So, any questions about testing before we start talking about test-driven development, since that's what you're all here for? Yeah. Go for it. Yep. Yeah, so the question was, let's say you've got some tests set up where you're not ever leaving your project, right? So you're setting up an in-memory database, let's say with Entity Framework or something like that. is that still considered an integration test if, like, you're using an in-memory database, you're mocking out external dependencies, things like that? In my opinion, if you're using like Web Application Factory, for instance, and spinning up like the server in memory and actually hitting those APIs, to me that's still an integration test because you're testing like how like your ASP.NET Core middleware plus your controllers and all that kind of stuff work. So to me, even though you're not hitting external stuff to your project, to me that's still an integration test because you're testing how multiple parts of your application integrate together. So that's how I define it, but like I said, lots of other people have different opinions. My opinion is just if you're integrating multiple parts of your system, to me that's still an integration test. Whether or not you're hitting external dependencies is kind of whole nother thing. So, cool. All right, so let's talk about test-driven development. So what is TDD? Where did it come from? So back in 2000, this guy named Kent Beck created this book, TDD by Example. And Kent Beck was part of a team, I think, at Chrysler, who was working on a particular project. I think it was like a payroll system. And he was starting to do some more extreme programming practices that those guys kind of came up with. And one of those practices was test-driven development. And so Kent ended up writing this book to talk about TDD. And I still think this is one of the best books about TDD. The examples are in Java. So even though I'm a C# person, it's not ideal for me, but I think it's, C# and Java are close enough that it's pretty similar, and I think the concepts from this book are pretty timeless. So that's kind of where TDD started getting its kickoff, was when this book got released in 2000 to talk about what test-driven development is and how to practice it. So if you're interested, I would still pick up that book today. I still think it's worth a read. So what is TDD? So it is a methodology for writing code, not tests. So a lot of people think that test-driven development is really about the tests, and while they are useful, to me that's not the most important part about TDD, and we'll talk about that in more depth a little bit later. So the idea behind TDD is you write the test before you actually write your production code, which can be kind of trippy for some people of like, how do I write the test before I actually write the real code that I'm going to write? Like, how do I even know what to test? We'll talk about that a little bit later. But essentially, that's a big part of what TDD is, and we'll talk about the different steps here in a second. But essentially, a big part of TDD is just you write the test before you write the production code. So how do I TDD? So a lot of people will think, how many people have heard the term red-green refactor? Okay, maybe 10% of the room. So a lot of people think that TDD starts with writing the failing test, but I actually like this concept that first you think about what you're trying to do, like what behavior are you trying to get out of your system? What like failure states could happen to this behavior? Like what's all involved, like what should you be testing, how should you be setting this up? So I think that's a key aspect, is you need to think about what you're doing before you actually start writing the next test. Then after you decide, okay, I decide what test I'm going to write, then you decide, okay, I'm going to write a test that describes what behavior I want to see out of the system that I'm about to create. So that's kind of where you initially write the test before you actually write the production code. And then you run the test to make sure it fails for the right reason, because you haven't actually written the real implementation production code yet. So therefore, your test should pass when you go to run it. Now, some people, like I know Uncle Bob from Clean Code, will say a compilation failure is sufficient for red. And to me, that's not sufficient for red, because I want to actually see that my test fails for the right reason, because I could totally set up my test and it passes when everything compiles, because I might have set up a mock that the way I set it up causes that test to never even fail in the first place. So I actually want to see the code compile and fail for the right reason. I'll show you a live demo of this here in a little bit. And then you write the code to make it pass. So some people will say you should write the minimum code to make it pass, and definitely there are times where I do that, but there are also times where I don't write the absolute minimum code to make it pass. So it kind of depends, but if you're just starting out, I would write the minimum code to make the test pass, and then run the test to see it pass. And then after you have that confidence that, hey, my system used to not do this thing, And now it does do this thing because you ran it first, it failed to prove that, like, hey, my system doesn't have this behavior yet. And now you've made the test pass to prove, okay, it does have this behavior now. Now you've got a refactor opportunity where you can say, like, hey, I'm going to make changes to how I did this implementation. That way, I've got that coverage to know, like, hey, I've got a test that covers me. So if I change how things work and I break it, my test is going to fail and catch any problem that I might have. And then you kind of repeat this cycle over and over and over again for the next piece of behavior that you're about to write. So it kind of looks something like this, if you're more of a visual person, where first you think, and then you write the failing test, and then you make that test pass, and then you go into this refactor mode until you're satisfied with how the code looks, and then you go back through this think cycle again. So this is where the term red-green refactor comes from, is because first you start with the red phase of writing a failing test, then you make it pass and make it green, and then you start refactoring, and you kind of get in this cycle of repeating this over and over and over again for the extent of your feature. So I really like this quote by Eric Evans. He said, if you haven't seen a test fail, you don't know if it actually works. So how many people have ever seen a test not test what the original thing it was intending to test? Okay, probably half the room. Yep. So that's a big thing with TDD, is if you don't actually see a failing red test, you don't know that what you just did targets the behavior that you're trying to capture with that test. And I've even seen people like set up a mock and then like test the mock directly, which doesn't really do anything either. So that's a key part of TDD, is if you don't ever see a test fail, you don't know if what you did was actually targeting what you're intending to target. So what is not TDD? Because a lot of people might use the term TDD when they probably didn't mean to. So the first thing is TDD is not a synonym for writing tests. So if somebody says, hey, I write tests, that doesn't necessarily that they're meaning they're doing TDD, even though they might say they're doing TDD. If they're not writing the test first, then they're not doing TDD by definition. And TDD is not writing a bunch of tests all up front before you write any production code whatsoever. So some people will say like, oh, I do TDD. I write, all of my test cases before I write any code. And that's pretty close, but really TDD is about getting in that cycle where you're just focused on one single test and making that single test pass, and then kind of repeating that cycle over and over and over again. And some people will be like, oh, I do TDD. That means I never will have bugs ever again, right? And that's also not the case. Just because you have tests and you do TDD does not mean that you'll never have bugs. So sometimes our managers need to be educated that, like, hey, just because we have tests doesn't mean we're going to catch all of our scenarios. Like, we might not think through a situation or something like that. And so if we never actually write the test covering that situation, then we're not actually going to be able to cover that scenario. As well as, let's say you've got an existing production code around a system, right? And you were like, oh, I want to write tests around this, so I'm going to TDD this. Like, by definition, you can't really TDD it because the existing production code already exists, right? So what you could do is you could write some tests around that system, like those characterization tests I was talking about, and then you could, if you want, you could, remove those lines and then run the test to see it fail afterwards. So that would indicate that, hey, I'm targeting what I'm intending to target, and then you can put that code back afterwards. So that's kind of close-ish to TDD, but still not exactly because, again, that production code already exists. However, I guess on a point on that, too, is some people will say, oh, I can't do test-driven development because I've got this legacy system. And that is absolutely not true. So what you can do is you can take the behavior that you're adding to your system and rip it out into a new class or a new method and test that method in isolation and then kind of drop it into the piece, to the place in your legacy system where it exists. So if you start doing this methodology, over time you'll get more and more tests around that legacy system, as opposed to this class is 5,000 lines long. What's another 10 lines amongst friends, right? But the problem is that's how all of that got started, right? It used to be 1,000 lines, and then 2,000 lines, and then now it's 5,000 lines. So if you start ripping that behavior out into separate methods or classes, then you'll start slowly extracting out some of that functionality and start to make your system better over time. The other thing is there is some test-driven development zealots out there who will say things like, hey, if you don't do TDD, you're writing bad code. And has anybody ever dealt with anybody like that where they say, hey, if you're not doing TDD, so a few hands out there, if you're not doing TDD, you write bad code. And I don't believe that at all. Like, I think that just does more harm than good. And it reminds me a lot of, like, being a C# dev. Sometimes I have said things about VB devs in the past that might not have been the nicest things on the planet. But like that kind of stuff just does more harm than good. So it's like, instead of saying like, oh, you write bad code if you write TDD, what if those people would spend that energy like teaching people how to do TDD, for instance? And I don't think if you don't do TDD, you're writing bad code. And honestly, even if you don't do TDD, I don't think that's like, I think the more important thing with TDD, and we'll talk about some of the benefits here in a second, is more just the iteration that you're doing. So some people do test after, where they're adding tests after they write the production code. And I think that's totally fine. I would just try and write tests immediately after you write some code, because I see some people who will be writing code for like days or even weeks, and then try and remember all the situations that they need to like backport tests after the fact. And I would instead if I'm doing test after, I would write some code and then write some tests immediately after, because I'm already in that state, versus like if I'm trying to think like what code I wrote like days or even weeks ago, I probably can't think of all the scenarios that I want to test. So even if you're doing test after, try and add tests like immediately after you write some production code would be my advice. So I bet you didn't think you'd hear people or hear some tips on test after in a TDD talk, but I recognize not everybody does TDD, so hopefully that tip helps. So like, why would you even go through this like red-green refactor phase? Like, what benefits are there? Post that up to all of you. What benefits could you see with doing this red-green refactor cycle? Miss bugs? Less bugs? Yep, less bugs. Yep, testing, focusing on the behavior first, yep. Same thing, all right. Better code, why? Yep, so you're refactoring kind of as you go, yeah. What's that? Feedback loop, yep, yeah, you have this very tight feedback loop that, did this code I just write actually work? I heard something over here, yep. Yep, you have code that's more easy to test. Yep, absolutely. Yeah. You actually prioritize it. Yeah. Has anybody ever had a manager like tell them, hey, don't spend time writing tests. Like, that's what the QA is for. We'll figure that out later. I just see some people smiling out there. Yep. Feel confident. Yep, absolutely. Yeah. Document the business logic. Yep, absolutely. Well, you guys stole my slide pretty much over here, but I know somebody mentioned something similar to this, but like you work in small steps. Like to me, that's one of the biggest value adds of TDD is you're working in these small steps, which minimizes your waste because you're not like, has anybody ever jumped into Codebase, start refactoring, and then like you're like, oh, I came across this thing, and I want to refactor that too, and then you come across another thing, and you're like, oh, I want to refactor that too. And like, then you're like, I see some heads nodding. Then I'm like 5 levels deep. I'm like, wait, what was I trying to do again? Oh yeah, this other thing, right? Back here. And so I find TDD helps me not like go down those rabbit holes where like I feel like I'm just like, I got a machete in a jungle and I'm just like hacking away and hoping at the end I end out of the jungle. Because TDD focuses me on just making the next test pass, which is nice. And it also minimizes your work in progress. Like I was saying, you're not going like 5 rabbit holes deep. You're just kind of focusing on making that next test pass. So to me, like this is the biggest thing with test-driven development is it gives me focus, because with my personality, sometimes I can lose focus and get distracted by other things. And so with TDD, it helps me focus on like, okay, I'm just trying to make this next test pass. And what I found too is you spend a lot less time in the debugger. So think about all the time that you spend in a debugger today. And what if I could tell you that all of that time just magically evaporates? Because what I found doing test-driven development is I don't actually spend very much time at all in the debugger. Like maybe a couple times a month, maybe, but I've gone like multiple months without even entering the debugger whatsoever. So like if you think about like, oh, this is going to slow me if you're thinking in your head like, oh, this is going to slow me down because, I have to write tests up front and all that kind of stuff. If you take all that time you spend in the debugger and put it towards tests, not only at the end will you get this test suite, but when you're debugging, essentially that debugging session goes away as soon as you hit stop. Versus with an automated test, you have that around forever, which is really nice. And TDD helps me think through all my failure states too, so I get to think through, because I'm just focused on this one little feature, I get to think through okay, what if somebody passes me a null, or what if somebody passes me, a number or something like that when a number less than 0, what happens to my system? And then, as we mentioned too, one of the biggest things is confidence that as you're writing code, you get confidence that what you're writing actually works because you see that test go from red to green. As well as, somebody mentioned testable code here as well. You get design feedback. So if you find that a test is really hard to write, that might be an indicator that your design isn't quite right. So if you think about, let's say you've got a 1,000-line method versus a 2-line method, which would you guess is probably easier to write a test for? I'm going to put my money probably on the 2-line method, not the 1,000-line method. So the other thing is you get nice design feedback on hey, if my test is hard to write, it might mean that my design's not quite right. So maybe I should rethink how I'm doing this. And as mentioned before, you can use it as you start adding new functionality to legacy apps. You can start isolating the new logic that you're writing in another test or another method or another class, and then kind of test that in isolation as you put it into your legacy app. And you notice, I didn't actually, any of these, I didn't really mention the tests too much, but at the end of the day, you get nice regression tests too. But honestly, to me, that's not the biggest benefit you get out of all this. I think all this other stuff is almost just as valuable as getting the regression tests that you get at the end of the day as well. All right, so the next question I get from people a lot is, what should I be testing exactly? So the number one thing I would say is test the behavior of what you're trying to do. So I used to be somebody who used mocks pretty heavily, and I still definitely use mocks, but I'm using them a lot less and less these days because I'm more focused on what's the behavior of my actual system versus hey, do I want to write a test that's saying hey, did I pass these parameters correctly and things like that. I try and avoid those tests as much as possible now. But a litmus test you could ask yourself is, can you delete production code from your application and does a test that breaks your app, and does a test break? If the answer is yes, you're probably missing a test. And so I like to think about this a lot of hey, if I just delete a logger statement, if I'm using ilogger in C# for instance, and I just delete a logger statement, does that break my application? Probably not. So usually I don't test hey, did I use the logger correctly or things like that, unless I was building something where the logger was very instrumental to what I was doing. So I might not write a test around hey, am I using the logger correctly? But if I can delete code that breaks my order function, place order functionality, and no test breaks, then there's probably a test that I'm missing, and I probably want to add a test there. So I would say this is probably one of the key takeaways of this talk is your litmus test should kind of be, if you can delete production code from your app that breaks your app, but no test breaks, then you're probably missing a test, unless for some reason the cost of creating and maintaining that test exceeds the value of the app breaking. But I found too that might be an opportunity to refactor the code depending on what it's doing. But yeah, this is a key takeaway out of here is if you can delete code that breaks your app and no test breaks, there's probably a problem. But the opposite is also true, is if your tests are broken but your app isn't, something also is kind of amiss. So do you have a flaky test where, I was calling out to an API, but the API went down, or I was talking to a shared database that was using some magic IDs that assumed to be in the database, but those got deleted by somebody, for instance. Or maybe there's something about my tests that are tightly coupled to the implementation details of my application. So those are all indicators that I should probably reevaluate my tests and not just click the this is a safe place I guess I won't ask the question, but some people, including myself, I've done this before, just click the rerun build button when a flaky test happens. And that's usually not what you want to do, because usually you should get to the root cause of like, I should root cause like, why did this test flake out? Because otherwise, that flaky test is probably going to be flaky sometime in the future. The other thing is, if you've heard of the concept of snapshot tests, where basically you kind of take the output of the system and kind of write it to a snapshot, usually like a JSON file, depending on what you're doing. And then you kind of compare the output of the method to that JSON file to see like, hey, does this match? I don't like using snapshots most of the time, because the problem is the snapshots don't really capture what behavior you're trying to go for. They don't really tell you like, hey, I expected, when I pass this data, I expect to get back this. They really just capture like what the current state of the system is. And you can't TDD snapshots either, because like snapshots rely on the implementation code to be there already. So I don't like snapshots from that aspect either. So I see a lot of people using snapshots, especially like front-end testing. I see a lot of people use snapshots as well, and I personally don't like snapshots. However, they can be useful when you're doing a huge refactor, and the output should be the same, but like how you get to that output is different. So for instance, if you're doing like Blazor or React or Angular, snapshots can be useful if you're like changing how the component creates the HTML, but the HTML should be completely the same. So I'll use snapshots in those cases and write a snapshot test, and then after I get done with it, I'll just delete that snapshot test because it's no longer useful. And honestly, there's like a lot of implementation details in snapshot tests where it's like testing CSS classes, how the HTML is structured, all that kind of stuff. That's usually not actually behavior. So that's another reason I don't like snapshots. All right, and I like this quote from Kent Beck. He said, I'm not a great programmer, I'm a good programmer with great habits. So you don't have to be this super amazing programmer to do TDD, and Kent Beck himself says he's not actually a great programmer, he just has great habits. All right, now it's time to do a live TDD example on this podium at a 45-degree angle, so feel free to judge away on how this goes. All right, so I've got this HR system that's kind of like keeping track of employees in your company and things like that. So I'm gonna have a validation class that's kind of like validating, some data about the employee. So I'm gonna make employee validator tests. Can everybody see that okay in the back? Seeing heads nod? Okay, thumbs up, cool. So I'm going to create this employee validator, and as part of that, I'm going to create this employee validator class. So a lot of times I'll say, just take the class name and then suffix tests onto it, or whatever I'm testing, and then suffix tests. And I'm going to, my test naming convention is usually I'm doing like the thing I'm testing, in this case a method, and then I'm going to say should do something, should return error when first name is null. So that's usually my default naming convention. I don't really care what you use as long as you're consistent. I don't really get too caught up on how people name things as long as you're consistent. So I'm going to create a new employee validator class. And writer was a little too helpful there. And you notice I don't have this class yet. So I'm going to go ahead and use writer and create the type for me, and I'm actually going to go ahead and move this, because I've got a core project. I'm going to just go ahead and move this over to my core project. That way it's kind of out of the way. So the next piece of this is I want to actually create an employee object. So I'm going to create an employee, spelled correctly. And you notice I also don't have an employee yet, so I'm going to go ahead and create the type. So again, this is kind of where I deviate from some TDD people who say like a compilation failure is a failure. I don't agree, because I've seen too many tests that were set up where they would never fail. So I'm going to go ahead and move that over here too. And the other piece of this is I need to actually set first name equal to null. So I'm going to go ahead and do that here. And again, I'll make it compile and switch this to a nullable string. And then now I've got some of the arrange part of my test set up. So now I need to actually do the act part. So I'm going to go ahead and say I'm going to create this list of validation failures validation errors. And I'm going to go ahead and call this errors and say it's going to be my validator, and I'm going to pass in my employee. And again, I don't have the result, or don't have validate here or validation errors, so I'm going to go ahead and create those. And I'm going to move you as well out. I'm going to move it to my core, and I'm just going to move it to the models folder. And now I'm going to go ahead and create this method. And you noticed something I did here was I intentionally was explicit about making my type, and also did some of this arrange step before doing my act step. And so when I, in my case, control dotted, it actually created out like, hey, here's my list of validation failures, and here's my employee type. So the order in which you do things can make refactoring a lot easier. But I like using var, so I'm going to go ahead and switch that back to var. And so now I'm going to say, hey, my errors should contain, and one thing to call out here, and Dennis is actually here as well, is I'm using a library called Fluent Validation as opposed to the built-in, assert dot whatever built into XUnit. So how many people have used Fluent Validation, Fluent assertions before? Did I say Fluent Validation? I meant Fluent assertions. Okay, about half the room, cool. So all Fluent assertions is it adds the should extension method on the object, and then you get some nice helper methods like should contain and things like that. So it reads a lot cleaner, reads a lot more readable, and they've got like a bunch of other helpers for like creating, comparing two objects to see if they're equivalent and things like that. So if you haven't used Fluent assertions, I'd highly recommend it because of all the reasons I just mentioned. Okay, so I'm going to make a new validation error saying, hey, this should contain this, and I'm going to say, hey, it should contain the employee first name. So I want to know what property failed, and then I'm going to say the message is first name is required. So something like that. Notice I don't have a constructor on this yet, so I'm going to go ahead and make that, and I'm actually going to decide to turn this into a record now. So I'm going to go ahead and turn this into a record and pass in that, and go ahead and say this is property name, and then error message. Oops, if I could spell error message correctly. Okay, cool. So I've got my validation error, and again, I like creating the actual code so that it compiles because, again, I think it tells you a lot more out of this than if you don't. If you just let a compilation failure indicate red. So I'm missing a semicolon here. So let me go ahead and run that test. So what I should get out of this is, if I put these side by side, is I should get a not implemented exception because I haven't actually written the code yet. And you notice that is exactly what I get, is I get a not implemented exception. Cool. So I'm going to rip this over here and collapse you. So now, what I need to do is I need to return a validation failure that says, hey, first name is required with the first name property. So the stupid thing I can do is I can just say return new list of validation errors, and just new up a validation error here and say, okay, name of employee dot first name, and say first name is required, right? So that's the simplest thing I could possibly do to make this test pass. So now, you notice I've got a green test. Cool. Problem is, you all know that that's probably not going to work out for me long term. So this is where the next step of TDD comes in, where I'm thinking about like, okay, what should I do next? Well, I do have a refactor opportunity because I just made my test green, but I'm not going to refactor quite yet. So I'm going to go ahead and make my next test and go ahead and duplicate this just in the interest of time and say I should not return an error when first name is not null. Right? So then all I need to do here is basically say, hey, this should be like something random. There's libraries out there like Bogus and things like that, but I'm just going to create a new GUID just to indicate to whoever's reading this that, hey, the value doesn't actually matter. It could be anything. And then I'm going to tell Fluent assertions, hey, this should not contain this validation error. So I'm going to go ahead and run that test. And you notice it fails because it's saying, hey, I expected this not to contain this, but it totally did, which is true because I just hard-coded it. So let's go ahead and refactor this out now. So I'm going to not highlight too much. I'm going to say, I'm going to go ahead and just do something simple like this and say, hey, I'm going to create a new list of errors. I'm going to return that. And I'm going to go ahead and grab my validation error here and just say, hey, if employee.firstname is equal to null, then go ahead and add this error here. Right? So I'm just going to do something simple there if I could type first name correctly. So I'm just going to do something simple like that and go ahead and rerun the tests. So now you should see that test passes, and if I rerun all of them, all of the tests pass. So this was an example of just kind of showing you kind of that flow of TDD and kind of how I go about it, where I actually create the different classes, different methods, all of those kinds of things as part of my TDD flow. But now we've got a refactor opportunity. So I'm starting to notice there's a lot of duplication here. So I notice like employee, for instance, is duplicated. So I'm going to trigger some people by moving that out into the constructor, because I like my constructors to kind of just have the happy path in them. And then I can start using that here as well and just say, hey, I shouldn't have deleted all that. I should have kept some of that. But I'm going to go ahead and say, hey, I'm just going to use employee.firstname here. And then go ahead and set that as well so I can rerun my tests, make sure everything's still good. And everything is cool. And so now I can start refactoring even further, right? So like I can take this validator, for instance, and move it up the constructor as well, so that way it runs before each test, and then I'm not newing this up. And so I'm just refactoring some duplication that I see throughout the test. And I can keep going too, like this validation error, for instance. I could rip that out as well. But hopefully you see the point of kind of like when you're in this refactor stage, you can start refactoring how different parts of your application work. But don't change both your test code and your production code at the same time. Change refactor 1, run the test, make sure it still passes, then run the next one so you don't accidentally screw something up where your test doesn't actually test what you were trying to test. Cool. So we got like 13 minutes here, so I'll just leave it at that for now. But we're going to take a slight TDD detour to talk about this guy. Does anybody know who this is? If anybody does, I'll be super impressed. It's a writer, yeah. Yep, it's a Russian writer, yes. So his name is Anton Chekhov. So what he said, he wrote plays, and so what he said was, hey, if you've got a gun hanging on a wall in like the first act, that gun better fire off in a later act, otherwise that gun shouldn't be hanging on the wall because it has no purpose, right? And so you might be wondering, okay, that's cool. Like I didn't know I was involved in for a history lesson. Like how does that apply to writing tests? So let's apply Chekhov's gun to testing here. So this is very similar to what we just did. But what is violating Chekhov's gun where everything that you see should have a purpose in this test? Yep, initializing all the fields, even though all you care about is last name, right? So we're initializing SpongeBob and his address and his birth date, even though it doesn't really matter to this test because all we care about is last name. That's all we care about right there. So what you could do in a refactor opportunity is you could rip that out, creating a customer out into its own method or another class or something, and then just explicitly set last name. So that's something that's useful. So now it's like pretty obvious, like, okay, this just is dealing with last name. But just like I did before, is I usually go next level, and I put my happy path in the setup of my test. So in XUnit, that's in the constructor. And then each test, I'm just kind of tweaking the sad path as you go. And so it's indicating like, hey, all we care about here is last name. But there's some other duplication here too with the customer validator. So like I'm newing up the customer validator in there too. So if I ever add a dependency, now I got to go change it in all my tests. So I also usually new up the system under test in the constructor as well and rip that out just like I did earlier as well. So if we kind of compare these two code bases at the end, you can see like one's got a lot more, I think there's like 12 lines of code there, or 10 lines of code, and this one's got 3. So we've just reduced like the amount of code that's in this test by like double. And so like if you're setting up mocks, for instance, and we can get into that a little bit later. If you're setting up mocks, I would set up the happy path of your mock inside of your constructor. That way you're not duplicating that everywhere, and just changing like the sad path of your mock in the tests, for instance. So I see a lot of people will do a bunch of setup that they could have ripped out into the constructor. So that's kind of Chekhov's gun applied to testing. So if you think about like as you're writing tests, does what I'm setting up actually apply to this test, and is there anything I could do to refactor that out? And now when you watch a TV show or a movie and you see a detail and you're like, oh, that's totally going to come back up later, and then it doesn't, you'll be sad and you'll realize that, like Game of Thrones, for instance, violates Chekhov's gun. All right. Sorry if I just triggered anybody by what happened with Game of Thrones. All right, so let's talk about different types of TDD as well. So there's a few different forms of TDD. So there's what's called bottom-up TDD or Detroit, but I like the word bottom-up. We'll talk about that in a second. And then there's also top-down or London or acceptance test-driven development is another form as well. So what bottom-up is basically you build the bottom-most layers of your application first. So what this means is, and fair warning, this is a trigger warning to some people because some people don't like repositories, if you've ever been following some of that craziness on Twitter. But what this means is like you would start with like your database layer, so like your repository first, maybe test that in isolation, and then slowly work your way up to like a service or a handler, depending on whatever your application's architecture is. And then eventually move up to the controller, and then also then like, at the end probably add an integration test for some happy paths and things like that as well. So what I've found is it's a lot easier to teach people bottom up than it is to teach somebody top-down test-driven development, because usually in top-down there's a lot more moving pieces going on, and bottom-up you're kind of stitching together like, oh, okay, I just created a repository, now I usually have a service or a handler that talks to the repository, so then you kind of like incrementally work your way up and you kind of know the different pieces that you've already created, versus top-down kind of takes the opposite approach of that, where basically you start with some sort of failing integration or acceptance test, and then you start with a controller and kind of test that in isolation, and then usually like you're like, oh, this controller talks to a service, so I'm going to go ahead and mock out the service and test that in isolation, or a handler or whatever you're doing. And then, that usually talks to a repository, so then I'm going to go ahead and mock that out. And so typically with top-down, things are pretty mock-heavy. So that can be a downside of top-down, is you're kind of starting with the topmost and then kind of working your way down. So these are kind of two different approaches for handling test-driven development. So neither style is correct, and actually kind of mix and match the two. So just pick the style that makes sense for you. Some people resonate with top-down. Like I know some people who I've worked with really like top-down, and some people really like bottom-up. It just kind of depends on what style makes sense for you. So I usually mix these. So I usually start with like a failing acceptance test and then kind of do bottom-up from there. So I kind of do a mix of top-down and bottom-up. But the reason for that is because I think having a failing acceptance test kind of targets me on like the user's behavior, and then I work my way up from there, and bottom-up just kind of resonates with me and makes a lot more sense to me. But sometimes I will delete the tests after I'm done at the end if I don't think that they're useful to keep around. So let's say I've got an acceptance test, and then there's only a happy path for that acceptance test, like there's no sad paths. The intermediate unit tests I create might not be useful because they're kind of duplicating what the acceptance test does. So sometimes I'll delete the unit tests and keep the acceptance tests around if I don't think that they're useful. But again, TDD focuses me. It adds clarity in what I'm working on. It helps me get design feedback. So those tests were still useful even if I'm not keeping them around at the end. So yeah, that's okay that they help me design. So I get this argument from people of like, I don't have time to write tests. I just got to ship, okay? And then I'm like, well, why don't you have time? And then they're like, well, I'm spending too much time like dealing with bug fixes because the code sucks because I didn't write tests, and you get in like this vicious cycle of like, you're just stuck doing so much support work because you don't have that confidence in those tests around it. Or I'll get this argument too of like, oh, my boss won't let me write tests, right? And so I like to think about this person Like, what if you were going in for surgery, and they're like, hey, this surgery is going to take like 10 hours. And you're like, you know what, doc, 10 hours doesn't work for me. How about you do it in an hour? Would you want to go to that surgeon who's like, okay, yeah, I can do that. I'll just use one stitch instead of 50. Like, I'll just, not clean my utensils, like all that kind of stuff. Is utensils the right word? Probably not. Tools. So like, think about this person and like, if you're cool with this person taking a shortcut, like, are you cool with this person taking shortcuts? Probably not. So you probably shouldn't be taking shortcuts a lot of times either. And the other thing I see is people say like, oh, I tried TDD and it just didn't work for me. And I'm like, cool, how long did you try TDD for? I don't know, like 30 minutes. And I'm like, oh, okay. Like, how long have you been doing .NET Dev? Oh, I don't know, 5, 10 years. Cool. Like, were you a good .NET Dev after 30 minutes? Probably not, right? So like, if you're interested in TDD and it's hard at first, just you can keep sticking with it because, again, you don't get better at things by not doing TDD. So if you're interested in TDD, you just kind of have to keep trying it, and eventually things will start to click a lot better as you keep going. But like one way you can get started is like the next time you have a bug report come in, you can say like, okay, I'm going to TDD this feature, because you could write a failing test that proves that bug exists, and then write the implementation code that proves that you fixed the bug, right? So like that's a really good place to start, is the next time you have a bug report come in, not that any of us ever write bugs ever, but if you were such a person that did, that's a good time to start doing TDD, is to create a bug, or create a failing test that proves that bug exists, and then make it pass to prove that you fixed it. All right, so we're at the end here. So some takeaways, hopefully, that you got out of this is just what kinds of tests are out there, like unit tests, integration tests, end-to-end tests, some ideas of why you should TDD and what to test, and then hopefully the Chekhov's gun example is useful, even if you're just not doing TDD and just writing tests. And then also, if you're interested in getting started, the next time you have a bug is a really good way to get started with TDD. Like I said, I have posted these slides up on my blog. It's just my first and last name, scottsauber.com, and I intentionally create them pretty detailed so you can remember what I said, because I always hate downloading slides and they're just like pictures, and I'm like, I don't remember what they said about this picture. So hopefully leaving them detailed helped. I do have a YouTube on TDDing React if you're interested, and then on November 9th, I'm giving a TDD webinar for Blazor specifically, where I'm going to be TDDing an entire feature on November 9th with JetBrains. So if you're interested in that, you can check that out. So with that, we've got a few minutes, 2 minutes for questions. Any questions anybody has? Yeah. Yep. 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 Yeah, so the question was around, like the employee has some rules around the first name should never be null, for instance, but the implementation says that it can be null. So like that object I had would probably be more like a request object from an API where like they could pass me a null, for instance, and I want to like gather up all the validation errors and kind of return them back. So that probably wouldn't be like the based employee class, for instance. It'd probably be like more like the request object. But yeah, there's some debate even in that space as well. Because I've seen some people who like return one validation error at a time, which from an API perspective is like not fun to deal with because you don't get all of those back at once. So, yeah.
So in the test, I saw that, I know that when you do rendering, the output is the test, but what about the think phase? Is there any like outputs from that usually? Is there any comments or documentation or something when you start? Yeah.
So the question was, are there any outputs after you run the tests of like what, like documentation or?
No, I think, so you have think, red, green, refactor.
Yep.
I think you kind of skip the thinking thing, part in your demo, so.
Yep. Yeah, so yeah, I guess I didn't think out loud because I had the demo in my head. So yeah, that's totally valid. Is that what you're saying? Okay, so I see what you're saying. So yeah, so you're saying what's the output after you think? Like, is there any documentation or things of that nature? I mean, I definitely have like done whiteboarding session, like whiteboarding thinking about things, but I usually don't have like a specific output. But sometimes I might like make notes to myself too, of like, okay, here's kind of where I think we should go, and things like that. So like, there's not really always a specific output out of the think step, but there totally can be if you want there to be. But I think the challenge is also not thinking too far ahead too. So like, don't try and like design it all up front. Just like design what you're initially trying to do. So yeah, and I find this is like really hard to talk in the abstract. So if you have a specific example, like we can talk through it afterwards. But yeah, generally like try and think enough, but not too much, which is a terrible answer. But I can give you a more specific example if you have one. Yeah. Do you want to repeat that question?
Hello.
Hey.
So my question is, what are some common pitfalls when developers start with TDD encounter?
Yep. So some common pitfalls I would say is if things are too tightly coupled to implementation details, where there's a lot of like, because like basically anytime you introduce a mock, you're kind of gluing your test code to your implementation details, and so sometimes when people use mocks too heavily, it can actually make refactoring harder because like their tests are kind of glued to their implementation details. So sometimes people will kind of, I guess, glue themselves to the implementation details, which then actually disables like a big refactoring versus enables refactoring. So that would be a downside. I guess the other thing is just people who are new to it. If you're brand new to it, sometimes it can be difficult to think about like, okay, I'm writing a test before I actually write any code and thinking through that situation. So for that, I try and think about like what behavior am I trying to see in my system, and can I focus on that?
Thank you.
Yep. Yeah, one more. If you have questions later, just come up after and I'll chat with you.
My question is about, you told about that we have two approaches, like from top down and from bottom up. I was thinking that when we have a clean architecture and we have centralized business logic, why should not we start from the middle? Is anything such kind of?
So that's a good question. So I guess bottom up is kind of depending on what your bottom is. So like if you do like have like your domain logic kind of in the center, for instance, you could start there too. Just eventually you're going to have to connect that up to something else. So it kind of depends on how your application's set up. So whatever bottom of your application is for you and what makes sense for you, don't get married to like you have to start with a database, for instance. You can just start at the bottom because sometimes we don't have a database, right? Like if you're just writing a library, there is no database in that case. So whatever the bottom of your application is to your entry point, that's kind of where you start and work your way up. So it's a good question. All right, we're a couple minutes over, so that's all I got. So if you have any questions, feel free to stop up. Otherwise, thanks, everybody.